Imagine you have a magic trick where you can turn pure invisible energy into actual physical solid objects. This is exactly what pair production is. It is the perfect real life example of Albert Einstein's famous equation E is equal to mc square, which proves that energy and mass are interchangeable. Let us dive deep into the pair production and understand it. This incredible interaction was first beautifully observed and explained by a brilliant physicist called Carl Anderson. He was awarded the Nobel Prize in Physics in 1936 for this exact discovery. Why was this discovery so special? Because Anderson's work provided the very first empirical proof of actual antimatter. He discovered the physical track of a newly created particle called the positron. This discovery created a massive paradigm shift in our understanding of physics. It definitely confirmed that pure electromagnetic energy could be completely converted into physical mass. Once again, pure electromagnetic energy could be completely converted into physical mass. It is the absolute perfect real life example of Albert Einstein's famous equation E equals mc squared. This single interaction proves beyond a doubt that energy and mass are completely interchangeable. Let us now look at exactly how this magical transformation happens deep inside your patient's tissue. We must understand exactly how this high energy interaction begins. An incredibly powerful X-ray photon penetrates deep into patient's atom. I said an incredibly powerful X-ray photon. But it does not behave like the photons in our previous interactions. It does not crash into the inner shell electrons like the photoelectric effect. And it does not hit the loosely bound outer electrons like the Compton effect. Instead, it completely ignores every single orbital electron. It bypasses all of the electron shell to approach the heavy nucleus. I showed you in my previous videos that surrounding this heavy nucleus is an incredibly strong electromagnetic field. This incoming incredibly powerful X-ray photon violently interacts with this intense nuclear field. This intense interaction is the absolute trigger for pair production. Let us see exactly what magical transformation happens to this photon next. We just learned that pair production creates actual physical mass out of pure energy. But the universe has very strict rules for this magical transformation to happen. There is a requirement of a minimum energy for pair production to happen. You cannot create physical mass for free. There is a very strict mathematical price to pay. Look at the two blocks on the screen. Albert Einstein's famous equation E equals mc squared proves that pure energy E and physical mass m are completely interchangeable. This equation means that physical mass is actually just a highly concentrated form of energy. The term resting mass energy refers to the specific amount of pure energy locked inside a particle when it is sitting completely still. If you take one single electron and completely converts its physical mass into pure energy, it will be equal to exactly 0.511 mega electron volts, or you can say 511 kilo electron volts. This specific energy value is a strict universal law of physics that can never be broken. That means to build the actual physical weight of one single electron from nothing, the universe demands exactly 0.511 mega electron volts of energy. Because this specific interaction must uniquely create two of these particles, we simply multiply this number by 2. We must create one electron and one positron. 0.511 plus 0.511. This gives us a total energy requirement of exactly 1.022 mega electron volts. Therefore, the incoming treatment photon must possess this mandatory threshold energy. This absolute minimum threshold is exactly 1.022 mega electron volts. What happens if the photon has less energy? If the incoming photon has an energy even slightly less than this, the Compton interaction simply will not happen. Pair production is physically impossible. The interaction simply cannot occur. Let us see the exact moment the magic happens. The incredibly powerful incident photon enters the intense electromagnetic field of the nucleus. During this violent interaction, the photon completely disappears. Its pure, invisible electromagnetic energy is instantly converted directly into physical mass. Once again, its pure, invisible electromagnetic energy is instantly converted directly into physical mass. Remember Albert Einstein's famous equation, E equals mc squared. From this pure energy, the universe successfully creates a pair of two brand new particles. A pair of two brand new particles. It creates one normal negatively charged electron. In medical physics, we sometimes call this a negatron. It also creates one positively charged positron. This newly created positron is a piece of actual physical antimatter. We have literally just watched pure energy transform into solid matter right inside the patient's tissue. We just saw that the incoming photon must pay a strict energy price to create physical mass. That absolute minimum price is exactly 1.022 mega electron volts. But what happens if the incoming treatment photon has much more energy than this strict threshold? What happens to all of that extra leftover energy? The strict laws of physics dictate that this leftover energy is never wasted. It is completely transferred to those two newly created particles. It is directly shared between the electron and the positron as pure kinetic energy. This kinetic energy is exactly what gives these particles their speed to violently travel through the patient's tissue. Look at this simple mathematical equation on your screen. The total available kinetic energy equals the original incident photon energy minus the 1.022 mega electron volt threshold. Now, how exactly is this leftover energy shared between the two new particles? Imagine two beakers filling with liquid like this. In medical physics, any proportional split of this energy is theoretically possible. However, the absolute most probable outcome is an exact 50-50 split. This means both the electron and the positron will most likely share the available kinetic energy completely equally. We just saw that standard pair production happens near the heavy nucleus of the atom. But what happens if the high energy photon interacts with an orbital electron instead? When this happens, we get a very special variant called triplet production. See here. The powerful incident photon strikes a loosely bound orbital electron. Just like before, the incident photon completely disappears. It magically creates a brand new electron and a brand new positron. But the violent crash also ejects the original orbital electron completely out of its shell. So we now have exactly three energetic particles violently moving through the tissue. We have the positron, the negatron, and the ejected orbital electron. This is exactly why we call this specific event a triplet. But this specific interaction comes with a much higher energy cost. Because it interacts with a tiny electron instead of the massive nuclear field, it requires double the starting energy. The new absolute minimum threshold to trigger this event is 2.04 mega electron volts. Mathematically, this is exactly 4 times the resting mass of a single electron. Why should you care about this in clinic? This triplet variant is extremely important when the beam passes through hydrogen-rich environments. But as the atomic number of tissue gets heavier, standard pair production completely takes over and dominates. Now let us look at the mathematical probability for standard pair production to happen. The probability of this interaction strictly increases as the energy of your incident photon increases. Once again, the probability of this interaction strictly increases as the energy of your incident photon increases. Specifically, the probability is directly proportional to the natural logarithm of the photon energy. The probability also depends heavily on the atomic number of the absorbing tissue. Mathematically, the probability per atom is directly proportional to the square of the atomic number. This is perfectly known as the Z squared rule. Because of this Z squared rule, pair production happens much more frequently in heavy, high Z materials like bone or lead. We must clearly understand exactly when pair production becomes the most important interaction in our clinic. Let us quickly review the entire photon interaction landscape. In human tissue, at very low diagnostic range energies, that means below 30 kilo electron volts, the photoelectric effect completely rules. As we enter the therapeutic range between 100 kilo electron volt and 10 mega electron volt, Compton scattering completely takes over. Now look at the extreme high energy side of the graph. We just learned that the absolute minimum starting line for pair production is 1.02 mega electron volts. But at this starting line, it is still far too weak interaction. Compton scattering still remains the massively dominant interaction in human soft tissue. It takes a very long time for pair production to finally catch up. Look at the dotted vertical line on the far right of your graph. It is only when we reach the extreme energy of 24 mega electron volts that pair production finally crosses over Compton scattering. At this extreme 24 mega electron volt mark, pair production officially becomes the absolute dominant interaction in soft tissue. You must always remember that 1.02 is simply the starting line, but 24 is the final crossover point. Let us look at the fate of the positron. We just saw the universe create a brand new positron out of pure energy. But what is the ultimate fate of this newly created particle? This is a very crucial concept for your daily clinical practice. You must always remember that this newly born positron is a piece of actual antimatter. Its existence inside the human tissue is incredibly violent and very brief. Let us follow its journey through the patient's body. As the positron travels, it constantly collides with the surrounding tissue atoms. With every single collision, it loses a little bit of its kinetic energy. Eventually, its velocity drops drastically near the end of its short range. It loses almost all of its speed and slows down to a complete stop. Look at the blue dot on the right side of your screen. When this slowly moving piece of antimatter finally comes to a rest, an inevitable encounters happen. It simply bumps into a normal negatively charged electron sitting freely in the tissue. What happens when antimatter directly touches normal matter? This encounter sets the stage for our final explosive subatomic reaction. Now we have reached the explosive finale of pair production. Look at the two particles moving toward the center of your screen. The orange particle is our newly created positron, which has now completely slowed down. The blue particle is a normal free electron sitting in the patient's tissue. When this piece of antimatter touches normal matter, a violent collision occurs. They violently combine, and their mutual destruction is absolute. Both particles are completely destroyed. Their physical mass completely disappears from existence. But the strict laws of physics dictate that this mass cannot just vanish into nothing. It is instantly converted back into pure electromagnetic energy. This is the absolute perfect reverse of Albert Einstein's famous equation E equals mc squared. Instead of turning energy into mass, The universe has just turned mass back into pure energy. This explosive event is strictly known as the annihilation reaction. Annihilation reaction. We just saw that the mass being completely converted back into pure energy. But the universe must strictly follow another fundamental rule. This is the strict law of conservation of momentum. Conservation of momentum. Because of this specific law, the annihilation event cannot simply release a single random flash of energy. It must brilliantly create exactly two brand new photons. Remember the strict energy price we discussed earlier. The resting mass of each destroyed particle is exactly 0.511 mega electron volt. Therefore, each of these two newly created photons possesses an exact energy of 511 kilo electron volt. But to perfectly conserve the momentum of the crash, they cannot travel in the same direction. The strict law of physics forces them to shoot away from each other. They travel in exact 180-degree opposite direction. This specific 180-degree geometry is the absolute key to our next physical slide. Let us quickly summarize the incredible journey we have just witnessed. We started with an incredibly powerful incident photon. This photon possessed a pure energy strictly greater than 1.022 mega electron volts. Look at the first half of the cycle on the left side of your screen. Here we saw pure invisible energy magically transform into actual physical mass. The incident photon completely disappeared to create an electron and a positron. Then this newly created positron traveled through the patient's tissue. During this journey, it slowly lost its kinetic energy through dissipation. When it finally came to a stop, it collided with a normal electron. Now look at the second half of the cycle on the right side of your screen. The two particles violently destroyed each other in the annihilation reaction. Their physical mass was instantly converted back into pure electromagnetic energy. This explosive event created two brand new 511 kilo electron volt photons. And these two photons were forced to exit at exactly 180 degrees from each other. What we have just seen is a perfect unbroken cycle of energy and mass conservation. First, pure energy becomes mass, and then that exact mass, same mass, becomes pure energy again. This beautiful continuous cycle is the ultimate summary of pair production. We just saw that annihilation reaction creates two photons traveling in exactly 180-degree opposite directions. How do we actually use this in our clinic? We use this exact subatomic physics for functional diagnostic imaging. This is the absolute fundamental basis of PET scan. First, we inject the patient with a specialized radiopharmaceutical. This specific substance actively emits positrons inside the patient's body. As we just learned, these newly emitted positrons will eventually slow down and collide with free electrons. This violent encounter triggers the annihilation reaction. This instantly fires two 511 kilo electron volts photon in exact opposite direction out of the patient's body. Now look at this circular diagram on your screen. The patient is lying safely inside a ring of special CT and PET detectors. These specific detectors are designed to capture both photons striking opposite side of the ring at the exact same instant. Because the photons are forced to travel at exactly 180 degree, the computer can draw a straight line between these two simultaneous hits. We clinically call this straight path the line of response. By using a back projection algorithm, this simple physics rule allows us to accurately pinpoint the exact location of the hidden tumor. We just saw how pair production is incredibly useful for diagnostic PET scans. But in our radiation oncology department, this exact same physics can become a massive danger. You must ask yourself a very practical clinical question. Why do we almost never use treatment beams higher than 15 or 18 megavolts in our modern clinic? If higher energy gives us deeper tissue penetration, why do we strictly stop there? You will be asked this in your Viva exams. The answer lies directly in the two massive radiotherapy challenges shown on your screen. First, there is a very serious problem of unwanted bone dose. Remember the strict Z squared rule we just learned earlier. The probability of pair production depends heavily on the square of the atomic number. We know that our bones are filled with heavy calcium, which has a very high atomic number. If you use an extreme high energy beam, pair production becomes the extremely dominant interaction. Because of this, the treatment beam is heavily and aggressively absorbed by the patient's bone. This creates completely unnecessary, dangerously high radiation doses to the healthy skeletal structures. We absolutely must protect our patients from this severe bone toxicity. Second problem for radiation oncology is a massive danger called neutron contamination. Neutron contamination. When your beam energy crosses extreme thresholds, typically about 10 to 15 mega electron volts, a completely new interaction is triggered. This dangerous interaction is called photodisintegration. The ultra high energy photons completely bypass the orbital electrons and crash directly into the actual atomic nucleus. This violent crash ejects fast neutrons directly out of the nucleus. These free flying fast neutrons are incredibly dangerous and highly lethal to human DNA. They flood your linear accelerator bunker and create a massive occupational safety hazard. To protect your staff from these neutrons, you are forced to build extensive, expensive, hydrogen-rich shielding inside your vault doors. This is exactly why mastering these specific interaction threshold is absolutely essential for your daily oncology practice. Understanding this physics strictly dictates our daily beam selection. our vault engineering, and the long-term safety of our patients. We have now covered the primary photon interactions that dictate your daily clinical practice. We saw the photoelectric effect interact with inner shell electrons to create our diagnostic image contrast. We saw Compton scattering interact with outer shell electrons to become the driving force behind our megavoltage radiotherapy. And we just watched pair production interact with the nuclear electromagnetic field to magically transform pure energy into actual physical mass. But our journey through photon physics is not quite over yet. There is one final extreme interaction we must deeply understand. What happens if an ultra high energy photon completely bypasses all of the orbital electrons? What if it also completely bypasses the nuclear electromagnetic field? What happens if this incredibly powerful photon crashes directly into the actual atomic nucleus itself? This brings us to our next major topic. It is called the photonuclear reaction, frequently known in your textbook as photodisintegration. In my next lecture, I will teach you exactly how this violent collisions shatters the atomic core and why understanding it is absolutely non-negotiable for the safety of your linear accelerator bunker. Thanks for watching. See you in next video. Signing off, Parveen Ahlawat.